Alright, here I've got the code for what I call the factor field. It's called the factor field because it graphically displays factors of numbers. It's not a very original title, but hey, it works, and that's all that really matters. The code for this is extremely simple. In order to run it, you just need to have a Windows machine. You get Notepad, copy in this code that you see here on the screen right now into Notepad, save it as a .vbs extension for the Visual Basic script. Once it's saved in there, you just double click on it and it'll run. Now, the only other program you'll need is Excel. You'll need Excel in order for this to show up because that's where I have it put the data to. And I should warn you that the script can take quite a bit of time depending on how big you want to make it. If you've got Office 2007, then the Excel spreadsheet in there is a lot larger than the 2003 version. I've got those numbers if you want to fill up an entire spreadsheet there. I haven't tested them, so you'll want to use them at your own risk, but those should be accurate. Right now they're just commented out. You just remove the comment for those, whichever one you want. It'll fill out the entire spreadsheet. It will be a huge file. I'll warn you that in advance. And it will take a long time to fill it up, even if you have a pretty fast machine. I do not have a fast machine, and I'm also running a bunch of stuff on it right now, so it will be extremely slow on my machine. I'm just going to do a quick 100 by 100 grid for demonstration here. You can see the code here. It's just one. Well, it's two loops nested, one within the other. That'll give you all the code there. I won't go into details of how that works. Hopefully you can look at it and figure it out if you know the codes. Otherwise I might do that in a future video. But for now, let's just run this, and it'll show how to come up. And again, it will go extremely slow on a machine because of how much stuff I'm running, like the recording software. So you can see it's filling up extremely slow. It'll go a lot faster on yours unless you have an extremely crappy machine. And once this gets a couple columns in, I'll go ahead and just pause my video recording and come back to it once it is completed. But as you can see right now, what it's doing is it's filling in the factors. So the first column is just all the ones. The second column is every other number, so 2, 4, 6, 8, etc. Third column is by threes, fourth column by 4, etc., etc., etc. And that'll go out to 100 by 100 grid. So I'll go ahead and pause the video now and come back to it when it's done. Okay, the code is now done, and as you can see, I have it where it pops up a scripting window telling you that it's done. That's because nothing is more annoying than not knowing if your script is completed or not, and then having to do a Control-Alt-Delete and see if the process is still running in order to find that out. So I just avoid all that by having it tell me when it's done. You can remove that if you want when you run the code. Anyway, now we have this all filled out for 100 rows and 100 columns. And I already think it's pretty interesting, but it helps if we put it into a correct perspective. So what I do is I just highlight all the cells, move this over, and I'll just do it 10 pixels by 10 pixels. And then once that comes up, you get a graph that looks like this. And like I said, this is just our 100, because row 100 is right there, 100 by 100. This is the factor field, and there's even in this top portion, there's a lot of interesting stuff that you can find in it. Well, we run again, it's just 100 rows, and one of the big features that you can see, every 6 rows, there seems to be this little spike, like here on row 6, row 12. Row 18 is not as big, but row 24 has one, row 30, and it's every 6. And if we scroll down here to row 60, you can see a pretty big spike there. And what's also interesting is wherever you have this spike come out, you can also see there's these little radial arms that come up, and they're at a 45-degree angle. The slope of this line here is 1-to-1 if you're counting rise over run. It's also got an identical slope going down, which would be the -1-to-1 slope on there. And that's if you just assume going up the factor field in on the vertical screen is positive values of y. It's actually not quite accurate because obviously going up we are going down the number line, but that's the way that it comes out here. So it's just natural to say, oh, it's going up, so it's 1 to 1, and then this one going down is minus 1 to 1. In addition to this slope 1 to 1, there's also a 2 to 1 slope, which is a little hard to see on here. I'll show some that are more pronounced later on, further down in it, but you can see that these do have some symmetry to it, and wherever there's gaps here, like the end here, you got 3 columns here, or sorry, yeah, 3 columns here where there's no factors, and then on the 4th column after it is another factor. And if you look up here, you've got a gap of 3 columns there, and then the 4th one has it. So wherever there is a gap here, it shows up in these radial arms that come out as well. And it also does it on the 2 to 1 slope. It's a little harder to see on here, just because this portion of the factor field is a little more compact and it's harder to find things. You can already see some other things, like you got these type of structures here, which there's another one down here, and you've got this here. These all look like origins of hyperbolas and parabolas and things like that, and I'll show you here in a minute, but those actually are all throughout this factor field. The symmetries on the numbers are just amazing, and it's stuff that you wouldn't necessarily ever know if you're trying to just calculate numbers. Once it's visually represented, you can see it. It's obvious, the symmetries going on, and you can see it on here. You've got this. Here's another 1 to 1. This would be negative 1 to 1 slope going down, and then the negative 2 to 1 going down here, and then negative 3 to 1 here, negative 4 to 1, etc. All these slopes originating from this point up there, and those kind of things are throughout this entire number line.